Good morning, everyone. It's my pleasure to be here with Dr. Martha Crosby. She and I are going to discuss something about computer history at UH. In the main lecture on Tuesday, Dr. Still talked about computer history in general. We thought you might be interested in some anecdotes here from UH. Our school has been proudly involved in several of the most important developments in computer science, and we'd like for you to hear a little bit about how they happen. So welcome, Dr. Crosby.
Oh, thank you, Dennis.
It's nice to have you here. Maybe you'll tell us a little bit about how you came to Hawaii and how you got involved at UH.
Well, I majored in mathematics, and I graduated at a time when it was pre-Sputnik. So there weren't too many people majoring in mathematics, and my first job then was to map the ionosphere on this 2K machine. And in doing that, I traveled back and forth to Washington, D.C., where I eventually took a job. And after about 10 years of working in systems and computers as they developed, my husband was sent to Hawaii in 1970, and we were supposed to stay 2 years, but obviously...
How many years has it
It's been 46. But, you know, Hawaii is a nice place to be.
Indeed it is.
And when I was working at Kentron when we first moved here, after mapping the ionosphere, I found a job mapping the ocean floors in the Department of Oceanography. But before that, I had worked at Kentron, where I was using punch card systems and Fortran languages to support the Kwajalein missile range. But people there had graduated from this new degree that they had at UH in information science. And this was something that engineering at that time didn't believe in computers, but we had moved into the arts and science college and were building our own computers. And so as I went to work for oceanography and started to map the ocean floor, I decided that I would get this degree, and that's where I met you.
Right. Dr. Crosby and I team taught together for a while in those early years. We knew most of the early faculty, and some of which we're going to talk about later in this podcast. Hopefully we can bring them to life for you a little bit, even though some of them have now passed or retired. So, but your current interests now are somewhat different than mapping the ionosphere.
That's true. As I began teaching and I began saying that computer science was not exactly obvious to all people, but the developers seemed to think that anybody could do this. And it turns out that if you can actually look at how people understand things, you can use computers to find out a lot about how they're processing the information. So a lot of what I do now is based on education and finding out cognitive load with the hopes of being able to make things, particularly like distance education, better and developing better tools.
Well, I think Dr. Crosby is being far too humble because she's very well known in the use of eye tracking equipment, where people actually watch the measurements, the movement of the eye to see what you're comprehending and what you're seeing. And I know you're very well known in that field, Dr. Crosby. She's being far too humble at the moment. Anyway, I think it's nice for you to get to know her a bit because next fall she will be hosting ICS 101. And so if you have a friend who is planning to take 101 next fall, you might pass this podcast on to them so that they can get to know their professor a little bit in advance of their coming into 101 in fall 2016. So I thought we would now talk a little bit about the role that the UH has played in the development of computer science. There are a number of very important elements in the development of computer science which have happened here, all of which are tied to particular personalities. We can give some anecdotes about them. So first is the emergence of the Internet. Actually, in those days, the piece that was here was called AlohaNet. Maybe you can tell us a little bit about it.
As I mentioned, I did take this first graduate course in information science, and at the time as a graduate student I was able to work on with Norm Abramson in something called the Aloha Project. And the Aloha Project was basically precursor to the internet. What it had was the ability to send packets, and what I did was write some of the FT forward transfer protocol packets that we sent little packets to the mainland, and the National Science Foundation gave Norm Averson a large grant in order to bring a computer here that could help process as a sort of a tip of this thing called the ARPANET, which is, again, is the precursor to the internet.
And did it work well?
It did.
Were we all surprised?
Well, I was surprised. But apparently even Metcalf came from California, and what I'm surprised about now is that this Aloha protocol is in cell phones today. So, I mean, they had versions, there was version 1, version 2, up to version 5, and then into Spread Aloha. But basically, the technology that is used today is in AlohaNet. We were the first place that ever used what we call fixed size packets, which is what the Aloha protocol does. Prior to that, whatever size the message was is whatever it was. So if you talked for 2 minutes, it was a 2-minute message. If you talked for an hour, it was an hour message. So you can imagine trying to have a big truck where you take all these different boxes of different sizes and trying to efficiently pack them into them. But Norm Averson said, look, let's just make them all the same size and then we'll put them together later. And that was really a huge breakthrough. And that was done right here at UH in the late 60s, early 70s.
That's really interesting. And are there any vestiges of this still remaining at UH, or is our networking theory still being worked at here?
It certainly is. Certainly is.
So anybody who wants to consider working in networking, you should be aware. We're including some of the slides from a presentation for you to see regarding this. So it's really one of the more interesting developments that have happened here. It was a little bit serendipitous because I think at the time, maybe Dr. Crosby, you can comment on this, I don't know if anyone really knew the importance of what they were doing.
No. Everything, in fact, we didn't even predict that there would be personal computers. There just, there was some things that went out to hobbyists, but basically it was sort of a mistake that a chemical company didn't quite meet the specifications. They didn't know what to do with the machine, so they threw it out to the hobbyists, and that's how we got Apple, that's how we got Microsoft, that's how we got, all of these very early computers. But nobody expected it. And even at UH, we had, these large computers, and at one time you and I taught this course where we had a very large computer that we wrote all of the software so that we could download it all on an 8080 for a class because we only had one of these small microprocessors.
So another big development was the whole history of time sharing. Now, I think it's hard for our students to kind of imagine how things were way back when essentially you would sign up for the use of the whole machine, or you would drop off your job at the bottom of Keller Hall, and you would submit it to run, and a few hours later, if you were lucky, maybe the next day, depending on how things went, you went to pick it up. And so I think there were people in the department who said, no, this isn't really how it should be. There should be a whole bunch of people using a computer at the same time. And so we now call this time sharing. But there were a couple of stories along the way about how this came about. And I thought maybe we could talk about what was then called the BCC 500, which was a computer. BCC, by the way, stands for Berkeley Computer Company. It came out of Cal Berkeley. And there was another interesting person associated with this. So what's your recollections of this whole process? And we're showing, by the way, a photo of Dr. Crosby with one of the magnetic discs from the BCC 500. No, that's not, a microcomputer. It's a disc which was 1 meter in diameter. So you can kind of imagine the size of the whole machine. I think maybe all the lights on campus would dim when Dr. Lichtenberger turned on this machine. I don't know.
Well, it was before they had the chips, right? See, so the microcode was on about the size of a window, and it was these plug things so that you could actually see where all the plugs went, and you could go and you could change it. The microcode itself was 90 bits long, so when it happened really fast, which gave this machine the possibility of nanosecond memory in the 1970s, which was really amazing. It had 3 kinds of storage, though. It had these very big disks, and the name BCC 500 was because it could use 500 interactive users. Now, at that time, Hewlett-Packard was boasting 32. So, this was really way ahead of the state of the art. It had 5 processors, so again, we already had the multi-processor system, and I had, before I moved to Hawaii, some experience working with operating systems with multi-processor systems. So when I was on the mainland, I had to go at 2 in the morning and hope for 10 minutes of time, but when I came to Hawaii, I was the only one with this experience. I had this machine to myself, and I was in heaven. It was a wonderful experience for me, and that was how we were able to develop a lot of the time-sharing things. However, we could have avoided this whole punch card history altogether if IBM hadn't been in the punch card business. I mean, they went into computers because they already had the punch cards with the census data, and they wanted computers for that purpose. But we could have had the time sharing and the with the mechanical relays way back 30 years before. But eventually we found that time sharing was actually better system, and even other parts of University of Hawaii had time sharing systems. So in addition to the BCC 500, which was housed in the College of Electrical Engineering, the computer center itself had 3 or 4 different kinds of systems, and IBM at that point had reluctantly gone into time sharing because it was the way the field was going, and so they had a system called TSO, and then we had another kind of system that Wes Peterson had helped to develop that was actually a lot more efficient than the TSO. But when you went into the computer lab, first of all, you had to, as Dr. Strebler had said, you had to put in your job and hope it would come out that day, which made you really careful about how you wrote your code, because you didn't want to have to keep going back for every little error. Imagine if every time that you made an error you had to wait a day, but that was the environment at the time.
Yeah, and I can remember submitting search jobs, search requests at Hamilton Library, and I would go to a librarian and I'd say, I'd like to search the literature for ABC. Please come back in 3 days and we will have done a search for you. So now, of course, with Google, things have speeded up considerably. So I think the whole process of interacting with computers has kind of gone through a cycle. We first had sort of standalone computers where, by the way, my time was always 3 in the morning. So I would get a slice of time at 3 in the morning. It was always 3. I don't know whether they were trying to punish me or what, but it was always 3 in the morning. And then we had the time-sharing machines, which allowed a whole bunch of people to use a computer at the same time. And then we went back to personal computers and smartphones, where presumably one person uses them and they're for them. So we've gone through this cycle, and I don't know where we're actually going to be heading with this. Do you think we may go back into truly a time-sharing environment one day as we get towards the cloud, or what do you think will happen?
Well, the cloud really is bringing us back to one standard, and of course Dr. Lichtenberger predicted that. He said, you're going to get so tired of all of these little discrete machines, you're going to want to put them all back together, because you're going to have networks stacked on top of other networks. But I think there's also going to be these distributed systems, because computers are ubiquitous. They're in everything, and so we're going to have a whole lot of problems, which is going to really up the importance of computer security, because we're going to have computers attached to us in very, very different ways.
Now, you mentioned Dr. Peterson. Dr. Peterson was one of the founders of our Department of Information Computer Science, and one of the things he's well known for is what's called error correcting codes and the CRC, the cyclic redundancy check. We're going to show a movie of a talk by Dr. Peterson, and after this movie we will join you again and discuss it.
And it turns out that this caught a lot of people's attention. This is a really neat way to detect errors. And so it became widely used. You remember the floppy disk? On every record on a floppy disk, they put one of these codes. We called it cyclic redundancy check, and that got shortened to CRC. And so every floppy disk had these CRCs on it to detect errors. It's also used widely on the networks. At least it's used on the packets on Ethernet. And Ethernet is the most widely used local area network, so they're everywhere. At this point in time, if you got a computer and a printer, you probably got a network, and if you got a network, you got Ethernet. If you got Ethernet, you got CRCs, even today. But they were on every floppy disk. Of course, the floppy disks have sort of disappeared. Anyway, that was fun.
Okay, we're back now, and so you've seen Dr. Peterson. He's unfortunately left us a few years ago, but he left behind a very wide and rich history of working in more of the theoretical aspects of computer science here in the department. What's your recollections of his work on the CRC and on error correcting codes?
Yeah. Again, this was something that he was interested in cyclic codes, and he worked a long time on cyclic codes. And it came, when he was working with other people and working with IBM, he found applications for that. And in order for this packet switching, which we mentioned before, to work, you didn't just send things out and then you put them together, but you sent them out with the idea that there would be errors. So you needed to have a very good theory about how to correct those errors. And so it was what he told me one time was the reason that he left mathematics and went into electrical engineering was because he didn't see the practicality of algebra. And what he did was, when he moved into electrical engineering, he brought modern algebra with him. And so now all of the everybody that's in engineering has to learn about error correcting, because that's how we make things work and make sure that things are correct.
And Dr. Peterson was recognized for this work and is really considered a giant in terms of the theories about error correction. We don't think about it every day, but your little smartphone even is making errors all the time, and we have to compensate for it. The errors, by the way, happen from fluctuations in power. They happen because of gamma rays hitting your chips. Many things can induce errors, and we have to presume there will always be errors and correct them as we go along.
And things are flying through the air, dropping bits as they go, and the ionosphere is coming in and
doing all kinds of crazy things. So really, to keep computers running, you have to say, okay, they will make some mistakes, but we will fix them. It's kind of counterintuitive. Usually we think computers are infallible and never make mistakes. It's quite the opposite, really. Now, the final thing we'll talk about in terms of the UH history in computer science is a project called Plato. And I'm sure all of you have heard of Dr. David Lassner. He happens now to be the president of the university. He was instrumental in getting Plato started. What's your remembrances of the Plato system?
So David Lassner came to UH in 1977 as a graduate student, and he came with this system called Plato. And Plato was almost what you now have on cell phones. It was the environment. It had touch screens. It was a cathode ray tube, but it gave you the ability to have kanji characters. It was time sharing across, using the ARPANET, so you could we had classes where we would talk to people in Japan, and this was really quite amazing for the early 70s.
And there was a room, I remember, full of Plato terminals. I don't know how many there were.
They had all of the terminals in one room, and
Yes.
what would happen is when you would go in, you would have to sign up for what system that you wanted to use. It would either be the HP, it would be TSO, or it would be the Plato. So you'd have to sign up on a little paper thing on the wall, and you would go in and use whichever system you wanted. We also had something called APL. We had a very like a typewriter kind of time sharing system.
And on the Plato terminals, as I recall, were different courses. Courseware, I guess, is what we call it now, where you could learn. I remember there were some in foreign languages, many in math. I don't know how many different topics were covered by Plato in those days, but quite a few.
Well, Professor Unger had done a lot with Japanese, and University of Hawaii was one of the places where they had a National Foreign Language Center, and we were one of the first ones to develop teaching kanji on computers. And again, that was something that was a very hard thing to do with the keyboards and the technology that we had at the time, but with Plato, you had the ability to have all sorts of graphics way before a good 20 years before it became popular.
So, okay, so that, students, is a little bit of a trip back memory lane into some of the major projects which happened here at UH in computer science. I thought it might be fun just to reminisce a little about changes in the campus and other things in life in Hawaii over this period of time. The first one is, when I walk around campus, when I was a student here in the 70s, the difference that I notice is there were no smartphones, of course. In fact, there were no phones at all. There were barely any phone booths. I remember there were a couple on the mall, and people would kind of line up because it was one of the few places on campus you could make any phone call at all. But there are many other things that have changed. What's different to you when you walk down the mall today, or when you're in Keller or one of the buildings that was already there? What comes back to mind of how it has changed?
Well, I think one of the things is the way we do distance education. In 1971, there was a moratorium on these big computers in the state, but it was very cheap for schools and for schools on the neighbor islands to rent teletypes. So because we had the BCC 500 and we had all of this time sharing capability, we were able to teach distance education in the early 70s, so what you saw was a lot of teletypes, which were a little bit noisy but cheap, $30
noisy
a month.
And slow.
But and 100 bits per second seemed to be a really fast innovation, right?
Right. No, and whenever Oceanic Time Warner talks about 100 megabits or something, both Dr. Crosby and I can remember the day where 100 bits per second was considered pretty blazing fast. So it really does prove the theory of relativity, I guess. But I remember when the 1200-bit, or as we call it, baud, 1200 baud modem, 1200 bits per second modem arrived. People said this was really fast. In fact, we had some computer scientists on the mainland tell us that things would never get faster. This was as fast as it would ever go. And of course, now we have many, many, many times more than that.
When I first started working in Boulder and flying to Washington, D.C. to use the computer there were 10 computers in the country, and they didn't think they could possibly use any more than 10.
Right. I guess they underestimated a little bit. By the way, the Lihing Mui mural on Keller Hall was just coming up. It was very, very brilliant colors. Every time I look at it today, I kind of see it's all kind of muted. So I think we really need to restore that Lihing Mui mural on the wall there. By the way, people were allowed to smoke on campus, smoke in classrooms, smoke in offices. So that's certainly a thing that has changed. And I also remember the lunch wagons lined up in Miley Way, some of who went commercial and opened restaurants in Hawaii as a result. But it was quite a feast of food at that time, for lunch here on campus. I'm afraid food has gone downhill since then.
The campus was beautiful. We had about a tenth of the number of buildings we have now, and it was mostly green spaces and flowers and trees.
Yes, that's right.
And a lot of them were open. Kuykendall was open, so the wind would go through the louvers. People would have to hold there.
Kuykendall now, I think, is less comfortable than now being air conditioned and shut up. The old days, the louvers, the trade winds would come in during class. It was really a very pleasant place to take a class. I don't know if this is progress or not to see all of this air conditioning, but that's nonetheless what's happened. Same with housing, of course, as well. Very few houses in those days were air conditioned. Now more and more of the condos at least are, which is kind of also a step backward, don't you think?
Yeah. One of the things that they did in the gym was they put solar panels, but then they built another building so that it blocked the sun.
Never underestimate the ability of humans to misplan, I guess. Anyway, I thought we'd talk about some of the current things. Many people don't know that there's a supercomputer hidden on Maui. It has some very special uses, and it's somewhat restricted, but next time you're in Kihei, you can see this site as you go down the Ho'opilani Highway. I've forgotten the name of the Ho'opilani Highway. Do you know something about the supercomputer?
I know it is open, and a lot of our scientists, particularly in oceanography and some of the chemists with the big data problems, do use the supercomputer. It's been managed. Our president, David Lasner, was able to get it on Maui and under the university for quite a while. And now the military does have some of it, but there still are ways, if you have big data and you have problems that you want to use a supercomputer for, you can.
I think all students have access if they have a problem that they can ask for use at that machine.
Right.
Very, 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 very powerful machine.
And it is one of the places, if you want to take a tour, you can go and you can look at the lights. It's kind of like when we first started, the lights will play and you can see which pathways things are going. And normally these things are too fast, but because there's so much of it going on, there's actually a visual display.
And then another big thing is the astronomy sites on the Big Island and Maui. This is another big source of jobs in computer science and in Hawaii, frankly, and is also leading the world in many ways because of the superiority of the optics on these sites. So I think this will be another growth area for Hawaii and will demand more and more computer scientists as well to run.
And one of the professors in our department, Dr. Kim Binstead, is actually doing a simulation of Mars, and you may have heard about the High Seas project, but if not, you should probably check it out. It's very interesting.
Yeah, no, Dr. Binstead lectured for the students this semester, and they got a taste of high seas. It's going to be very interesting this summer when these people who have been quarantined in this small space for a year sort of re-emerge into the real world. It'll be interesting to see how it goes. But yes, there's lots of research because both Haleakala and Mauna Loa have resemblance to planets because of the topology there, the terrain there. On the downside, we've also lost a lot of computer science jobs. There are these high-tech jobs that have still remained that we've talked about on places like the Maui supercomputer and the astronomy sites. But we did lose jobs from many of the main industries like airlines and banks and the health centers who have since that time outsourced many of their jobs to the companies on the mainland where they can do it more cheaply and get standard products instead of custom-made ones. What do you think the trend will be in the future Dr. Crosby, for people who are looking for jobs in computer science?
I think things might come back again. You know, we have this tendency for things to come and go and come and go. And I think that Hawaii is going to be more important again because, again, of our location and our focus on Asia. I also because things will be so distributed. There'll be a lot more niche markets.
One of the enablers for this will be to get really, really good cables so that we can have really, really good connectivity. I know Dr. Lassner has been fighting for this. Unfortunately, at the moment, we're losing out. We need more connectivity, but maybe that will change. Maybe the legislature and then all the parties involved will begin to realize the importance of this as an enabler for the future economy. Because both Dr. Crosby and I are interested in the future of students that come through UH, and we want you all to have bright futures if you decide to live in Hawaii.
Well, one thing we're not good at is predicting what's really going to happen. No matter how hard we try, we're not so good at predicting, particularly with technology. We think things, I remember when they first started doing natural language processing, they thought, in 5 more years it'll be perfect, and that was in the 60s. But we've come a long way, and I think it's going to be exciting to see.
I agree with you very much. Well, I think we've babbled on quite long enough, used your time. Thank you for listening. In conclusion, what does it all mean? How should students prepare themselves today, do you think, for the future? What's your advice to students about how to be prepared for changes that we can't predict?
I think knowing about history, one of the reasons we're even telling you all of this is because it does tend to repeat itself. So if you actually look at the info bits that we've given the link for, and you can see from the 90s how things used to be, not that long ago, maybe just when you were being born, but read about that and then notice, how things come in cycles, because all of these things you're learning are tools, and how you use them and when you use them changes. But the more you know about them, the better prepared you will be.
Well, it's been our pleasure to have Dr. Crosby here today, and I hope you've enjoyed this short ramble down Reminiscence Square, and we look forward to seeing you in person this semester and next. So, signing out.
Yeah.
Thanks, everyone.